So this is our hybrid model. Hybrid model just makes the circuit analysis simple. It is mostly not used in practice for digital application. It is used in analog application when we need to find out the input impedance, output impedance, voltage gain, and current gain. These parameters are useful for making amplifier circuits and filters. The RE model, as we have discussed in our earlier discussion, has the advantage that the parameters are defined by the actual operating conditions, whereas the parameters of the hybrid equivalent circuit are defined in general terms for any operating condition. So in other words, hybrid parameters may not reflect the actual operating conditions but simply provide an indication of the level of each parameter to expect for general use. So we begin our discussion in the hybrid model with the approximate hybrid. So we have to change this circuit into an AC equivalent model. So in your approximate hybrid model or hybrid model, its IE is already given. So we don't need to use DC analysis in order for us to solve for RE because its IE is already given. So this is if it is a common emitter, its IE is given. If it is a common base, it is called HIB. So we begin our solution in solving for our input impedance. So before we can get your impedance I and impedance IN, so we have first to solve for our impedance of the base. So first, we have to get the equation of the voltage at the base. It is equivalent to HIE-IB plus RE-IE. Then getting the equation of IE at the emitter, we have IE is equals to IB plus HFE-IB plus I. And our I, that is from BO, it goes to BE. So therefore, I is equals to BO minus BE all over 1 over HOE. So why it is called 1 over HOE? Why not HOE? Remember, HOE is a conductance with a units of Siemens. So we have to make that HOE into a ohms or resistance. So that's why that is 1 over HOE to make it a resistance. So we can rewrite our I as BO minus BE HOE. Our BO is equals to negative RL in parallel with RC IO prime, and our BE is equals to RE times IE. And if we have to get the equation of your IO prime at the collector terminal, so we have IO prime is equals to HFE IB plus I. And then we have to substitute the equation for our I, which is BO minus BE, HOE, and also to substitute the equation of BO as well as BE. Then if we have to combine all IO prime to the left side, then we have this IO prime and factor IO prime because IO prime is common. Then cross multiply. So we have IO prime equation in terms of IB and IE. Then our IE is equals to IB plus IO prime. So remember, IE is equals to IB plus HFE plus I, but IO prime is equals to HFE IB plus I. So we can write IE equals to IB plus IO prime. Then we have to substitute this equation of IO prime to IE. Then we have to combine all IE to the left side. Then we have to get the common denominator of both sides and cross multiply. So this is our equation of our IE. We have to substitute this one to our voltage at the base. Voltage at the base, it is equals to HIE IB plus RE times IE. So substituting IE to the voltage at the base, so our equation of the voltage at the base is now equals to this one with IB. So if we have to divide your voltage at the base equation with IB, then that will be our impedance at the base. Getting impedance I, we have RB in parallel with impedance at the base, and getting impedance IN, just add RS to the impedance I. Output impedance. Setting BS to 0, so therefore output impedance equals to RS parallel with RB plus HIE parallel with RE plus 1 over HOE parallel with RC and parallel with RL. For the voltage gain, it is B over Bs. So we have BO equals to negative RL in parallel with RC IO prime. Then IO prime, we have that equation already in the previous slide. Then IE is equals to IB plus IO prime. You have to substitute your IE to IO prime and get all IO prime to the left side. So we have this equation of our IO prime in terms of IB. So we have to substitute this one to our BO equation, which is negative RL in parallel with RC IO prime. So our BO now is in terms of IB. For our B input that is equivalent to the voltage at the base, we have already the voltage at the base equation. So this is now our voltage input. If we have to get the ratio BO over BI, that will be our voltage gain. Since our input voltage is Bs, so we have BO over Bs for our EBS. It is also equivalent to BO over BI times BI over Bs. So therefore, we have EBS equals to voltage gain, that is B over BI, times impedance I over impedance IN. For current gain, we have to use the ABS equation. So EIS equals to negative EBS times impedance IN over RL. For the complete hybrid, we have now HIE. So this is common emitter, so that's why it is HIE, HRE, HFE, and HOA. So if it is a common base, just change the subscript into B. So we have HIB, HRB, HFB, and HOB. So in this situation, first we have to solve for the current gain. So we have IO at the collector equals to HFEIB plus I, and RI is equals to BO minus BE HOE. BO is negative RL parallel RC IO prime, and BE is RE times IE. We have to substitute this one to our IO prime. Then our IE at the emitter is equals to IB plus HFE IB plus I, or that is equals to IE equals to IB plus IO prime. Then substituting this IE to your equation IO prime, then combining all IO prime to the left side, then we have to get the ratio between IO prime and IB, and we call this one as current gain prime IB. So for the current gain prime IB, we have this equation. Since our current input is IS, so we have EIS or IO over IS. And it can be written also as IO over IO prime times IO prime over IB and IB over IS. So for the ratio IO prime over or IO over IO prime, that is equals to RC over RC plus RL. And for IB over IS, that is RB over RB plus impedance at the base. So therefore, EIS equals to this equation, but we don't know yet the impedance at the base. So we have to solve for the impedance at the base. So that is solving the input impedance. So first, we have to solve impedance at the base using the voltage at the base. So we have HIE IB plus HRE BO plus RE times IE. And we know already IE is equals to IB plus IO prime. So BO, we have this equation for BO with IO prime equation. So we have to substitute your BO to your voltage at the base, combining all IO prime and substituting the equation of IO primes in terms of IB. So therefore, we have now an equation of our voltage at the base in terms of IB. If we have to divide this equation with IB, then we have our impedance at the base. So being for the impedance I, so we have RB in parallel with impedance at the base, and impedance IN is just adding RS to impedance I. For the voltage gain, that is BO over BS. So it can be written as BO over BI times BI over BS. So we have BO equals to negative RL in parallel with RC IO prime. We have already the equation of our IO prime. Substituting this one to our BO, or we can rewrite our BO if we have to get the ratio IO prime over IB, that is equivalent to our current gain prime IB. So we have this equation as negative RL in parallel with RC times current gain prime IB times IB. Then for our voltage input is the same as voltage at the base. So we have this voltage at the base in terms of IB, or we can rewrite voltage at the base as impedance base times IB. So therefore our BO over BI is equals to negative RL in parallel with RC times current gain prime IB over impedance at the base. Solving for the EBS, which is BO over BS, that is voltage gain, which is B over BI times impedance I over impedance IN. For output impedance, setting BS to 0. So first, we have to solve for your output impedance prime, that is before RC. So first, also, we have to get the equation of RIE as well as IO prime. Then IE can be expressed as IB plus IO prime. Then we have already the equation of RI, also RBE. Then next, since BS is set to 0, then we have to get the equation of your voltage at the input side. So that is RS now is in parallel with RB together with HIE, then the current flowing on both resistance is IB. So we have this negative HIE plus RS in parallel with RB times IB minus HRABO minus REIE equals to 0. Then we have to substitute the equation of IE And our IB now is equals to this one. So combining all IB to your left side and get the equation of IB. Then IO prime is equals to H if EIB plus I, where I is BO minus RE times IE. Then IE is equals to IB plus IO prime. Then we have to combine all IO prime. Then we have the equation of our IB. Substituting this one to our IO prime. Then combining all IO prime to the left side. So our equation now is in terms of IO prime and BO. If we have to divide BO over IO prime, that will be our output impedance prime. So this is now our output impedance prime. So get your output impedance. So we have output impedance prime is in parallel with RC and in parallel with RL. So that's all for our hybrid model.